Furthermore, when an interrupt first occurs and we're in this top part of the interrupt handler, it may be necessary to disable certain interrupts. We said that's one way to prevent the deadlock situation. But then when the interrupt handling is passed to a separate thread, then we can enable any interrupts that we had disabled originally, because now this is a separate thread. So interrupts occurring can be handled in the same way as it would for any other thread in the system. So there isn't any danger of some additional deadlock situations because we are executing in an interrupt handling routine. So basically, it is much safer in terms of having external interrupts occur when we are executing in this bottom part of the handling code. I intentionally chose the words top and bottom to describe what's happening in this situation because this description of how Solaris uses threads to handle interrupts is a very common technique how we allow the interrupt handling routine to potentially have arbitrary complexity and not be worried about deadlocks. In Linux, these two parts of the interrupt processing are referred to as the top half and the bottom half. So this is really what we illustrate with this portion of the lesson. The top half will perform a minimum amount of processing, and it's required to be non-blocking. It will be fast, basically. The bottom half is pretty much allowed to perform arbitrary types of processing operations. The top half executes immediately when an interrupt occurs, whereas the bottom half, like any other thread, can be scheduled for a later time. It can block. And so other than perhaps because of certain timeouts that are associated with the device, we're not really restricted when it actually gets to execute. The paper goes into further detail to describe a specific policy as to how to interpret the priority levels that are associated with the threads when they're being interrupted, also priority levels associated with the devices, and then use these priority levels in deciding when and how a thread should be used to handle the particular interrupt. And we will skip that discussion. But the takeaway is that if you want to permit arbitrary functionality to be incorporated in the interrupt handling operations, then you really need to make sure that that handling routine is executed by another thread that you can potentially synchronize with, and that thread potentially is allowed to block.